This is Professor Belden. This is Trigonometry. This is Chapter 3, Section 3, Law of Cosines. This is Part 2 of 2. So now we're going to do some word problems and some area problems. So, two airplanes leave the same airport. So this is our airport here where B is. Right, so that's our airport right here. And one goes north by 66 degrees west, and the one goes south by 26 degrees west. What's important here is those are not the angles of a triangle. You have to figure those out later in most cases. And the other thing is, the distances given are not the distances necessarily on the graph or the picture, because these are miles per hour, which are speeds, for a course of 2 hours. So as a result, you're going to get 650 miles and 600 miles when you go that speed over 2 hours. Okay? Okay. Now we've established our components. We know this is a straight angle all the way across. That's 180 degrees. So 66 plus 26 will give us 92 degrees, which when we subtract those leaves us with 88 degrees. So that is our remaining angle. So we have one angle across on the missing side, which will work well for our law of cosines. So therefore, b squared, the two sides we know are 650 and 600. So 650 and 600 times the cosine of the only angle we know, which is 88. And we can do our math. So b squared equals 422,500 plus 360,000 minus 780,000 times the cosine of 88. So therefore, b equals the square root of what's remaining. So if I add those two numbers together, I'll get 782,500 minus 780,000 times the cosine of 88. So in the calculator, that's going to be approximately 869 miles, which is reasonable. Has to be longer than the other two, given it's the biggest angle in the triangle. Pause the video. Try the student problem. Okay, so we have an airport again, so we'll draw an A over here for airport. And we'll draw our compass, north-south. The first one goes directly north, so that's fine. So we'll just go up with the compass line. The other one goes north by 75 east, so he goes 75 degrees. All right, so we'll put our planes. I guess we don't have to name the planes either way. So we want to figure out that distance between the two planes now. Well, the key here is they went 3 hours at these speeds. So therefore, it's not 400 and 350, it's 3 times that. So this one had to have gone 1,200 miles. And the other one is 350 times 3 had to be 10,050 miles as a result. Okay, so we'll use our law of cosines. So d squared equals 1,200 squared plus 1050 squared minus 2 times 1,200 times 1050 times the angle, which is the cosine of 75. Move this out of the way. So d squared equals 144,000 plus 1,102,500 minus 2,520,00 times cosine of 75. Oh, forgot one more zero in there. So d equals the square root of, so we'll add those two numbers together. We get 2,542,500. Make a better 2 than that. Minus the 2,520,000 times the cosine of 75 degrees. So in our calculator, that's going to give us a distance that's approximately 1,375 miles is the distance between the two planes after 3 hours. Okay, let's try the next page. So previously we did the area of triangles, and we discussed the grade school formula, which is half the base times the height, and we did an area formula for oblique triangles, but that one required angles. This one, Heron's formula, does not require angles. You just need all the sides. So when you have all sides, you use this formula. So the difference being here is we first need to calculate what's called semi-perimeter or half perimeter, depending on which textbook you pick up, which is half the sum of the side lengths. So in this case, the semi-perimeter is 1/2 the sum of the sides, which is 12 plus 16 plus 24. So that's 1/2 of 52. So that in fact is 26 yards for our semi-perimeter. So we know we can do our formula. So the area equals the square root of the 26 minus, 26 minus, and 26 minus. And we can fill in the numbers. 12, 16, 24. So the area equals, what you should notice is the order that you put them in doesn't matter, because you'll get a series of multiples and the order doesn't matter. So we're going to get 26, 14, 10, and 2. So that gives me an area of the square root of 7,280. So that area, when I square root it, is approximately 85.3. So this is in fact the wrong answer because we didn't label it. It's going to be yards squared because it's square feet, square meters, square yards for area, which makes sense because this is yards times yards times yards times yards, which is yards to the 4th power. And the square root of the fourth power, right? 4th power is 2nd power. Pause the video, try the student problem. Okay, for the student problem, find the semi-perimeter or half perimeter. So that's 6 plus 16 plus 18. So S equals 1/2 of 40 or 20. And this one is in meters. Right? So it was meters, 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 meters. So my area equals the square root of 20, 20 minus, 20 minus, and 20 minus. So in this case we have 6, 16, and 18. So the area is 20 meters times the 14 meters times the 4 meters times the 2 meters. So the area is the square root of 2,240 meters to the 4th power. So the area, when square rooted, is approximately 47.3 meters squared. And that is the end of part 2.